Okay, so at this point, we've looked at a lot of different types of algebra, how to work with fractions, exponents, combining like terms, distributive property, all of that stuff. But we haven't actually solved any equations, we've just kind of used the different properties. So in this video, we're going to go over some different types of equations we can solve and the methods to solving them. This is probably going to take a few videos because there's several different types of equations we want to go over. First off, we're going to look at what's called radical equations. A radical equation is essentially an equation with a radical, a square root inside of it, and more to the point, with an x inside of the square root. So as an example, suppose we have something like the square root of x plus 1 plus 3 equals 6. And now in this case, I'm kind of left with, well, what do I do to go about solving that? And there's kind of a rule in algebra that when something causes a problem in an equation, you isolate it and deal with it, and then you go from there. In this case, clearly this radical is kind of the new thing that we have to deal with. That's what's causing the problem. So isolate it. Just do your regular algebra and isolate that. In order to do that, subtract the 3 from both sides. If I do that, I get the square root of x plus 1 equals 6 minus 3, 3. Now that I've isolated the radical, now I can deal with it. How do you get rid of a square root? You square it. But whatever I do on the left, I have to do on the right. On the left, the square root square cancels, and I'm left with x plus 1 equals 3 squared, 9. Now that's easy enough to solve. Subtract the 1 and you get x equals 9 minus 1, which is 8. The one thing I'll point out here for these types of equations and for all the equations we're going to do in this section, you can get what's called extraneous solutions. Extraneous solutions are essentially solutions that don't work. They're not solutions. They pop up with the algebra you do to solve the problem. All that really means is, for the problems we're going to solve, check your work. If it works, you're fine. If it doesn't work, that means it's an extraneous solution. In this case, if I plug in 8, I get the square root of 8 plus 1 plus 3 equals 6. The 8 plus 1 is 9. The square root of 9 is 3. So I get 3 plus 3 equals 6, which is certainly true. So there's no extraneous solutions there, and we're good. But let's see. There's lots of different ways we can mess around with these radical equations. So suppose we have something like this. The square root of 2x minus x equals negative 4. I still have a radical with an x inside of it. In this case, I also have an x on the outside of it. But the problem is always going to be the radical with an x in it. So isolate it. In this case, add the x to the left. You get the square root of 2x equals x minus 4. Now I've isolated the radical. Square both sides. Just be aware when you do this, I square the left, I square the right. On the left, the square root square cancels, you get 2x. On the right, you do not just square the x in the 4, you have to FOIL that out. You have to square everything. I'm sure you can all FOIL this in your head, but just to write it out, x minus 4 times x minus 4, that's x squared minus 4x minus 4x plus 16. So that's x squared minus 8x plus 16. Now, just solve that. The radical is gone. In this case, now I have a quadratic equation, so solve the quadratic. Set it equal to 0 and go from there. So I'll bring the 2x over. 0 equals x squared. Let's see. Minus 8x minus 2x is minus 10x plus 16. And now I just need to factor that. Let's see. Two numbers that multiply to 16 that add to negative 10, negative 8 and negative 2. And then of course we know when I set those to 0, I get x equals 8 and x equals 2. And then the last thing I'm going to do, plug those in to see if they're extraneous. If I plug in the 8, I get the square root of 2 times 8, which is 16, minus 8 equals negative 4. The square root of 16 is 4. 4 minus 8 equals negative 4. That's definitely true, so we're good. If I plug in 2, let's see, I get the square root. 2 times 2 is 4, minus 2 equals negative 4. The square root of 4 is 2, so I get 2 minus 2 equals negative 4. So 0 equals negative 4. That's certainly not true. That doesn't work, which means 2 doesn't work. It's an extraneous solution. That's the only one that counts. Okay, there are lots of different ways to solve these radical equations, but that should at least give you kind of a rough idea of how to work through the algebra to get them done. Let's see, time-wise, oh, we're good. The next type of equation we want to look at is what's called a rational equation. And essentially, rational equations, rational expressions, we work with those, they're fractions. But in the same way that a radical equation has an x inside the radical, we want to look at equations with x's in the denominator of a fraction. 1 over 2x plus 1 over 3 equals 4. And again, now we say, what's the problem? And, well, in this case, the problem is the x I'm solving for is in the denominator of a fraction. So we kind of sort of want to do what we did with the radical equations, isolate the problem. It's a little bit harder here, so we can actually use a somewhat different trick. When solving equations with fractions, you can always clear the fractions to get rid of them. And if we do that here, that'll make this easier. And to clear fractions, all we do is find the common denominator for all the different fractions in the problem. In this case, that's a 2x, that's a 3. So the common denominator will be 6x. Multiply everything by that. Once you know what you're doing, you can kind of do this clearing fractions in your head. But to make sure we're clear, if this is the first time you're seeing it, I'll write the whole thing out. Now distribute the 6x into each term. 6x times 1 is 6x over 2x, plus 6x times 1 is 6x over 3, equals 6x times 4, which is 24x. Now cancel and reduce. 6 over 2 is 3, and the x's cancel, plus 6 over 3 is 2x, equals 24x. And now I have a nice simple equation, no fractions. I can solve for x and be good. Subtract the 2x over. 3 equals 24x minus 2x, which is 22x. And then divide the 22. X equals 3 over 22. As far as it goes, this trick, clearing fractions, multiplying by the LCM, as long as you multiply by the LCM, the common denominator, it has to clear the fractions out. That's why we do it, which means if this doesn't work, if you end up with fractions here, you either multiplied by the wrong thing up top, or you reduce things incorrectly here. This trick has to work. The only other thing to check is, much like with radical equations, you can get extraneous solutions here. In this case, though, any extraneous solution you get will just be something that would make that original equation undefined. So all you really have to do, I don't want to plug that in and check it all out and do all the arithmetic out. All you really have to check is, if I plug that x in, will it make the denominator 0? And in this case, clearly, 2 times 3 over 22 is not 0. So whatever that is isn't 0. So I'm fine, and that's not going to be extraneous. So, suppose we have this. Let's see. 2 over x minus 1 plus 3 over x plus 1 equals 1. We want to solve this out, and we might not go the whole way through for this one because it might take a while, but we can at least work through the algebra to see what's going on. Again, I have rational expressions with x's in the denominator, so I'm going to multiply by the LCM. In this case, I have an x minus 1 and an x plus 1, so just like when we were adding and subtracting fractions, I multiply those together, and my LCM is x minus 1, x plus 1. Now when I multiply, I get 2 times x minus 1, x plus 1, all over x minus 1, plus 3 times x minus 1, x plus 1, all over x plus 1, equals 1 times x minus 1, x plus 1. As I said, once you know what you're doing, you can kind of shortcut this and save yourself some time. But here, the x minus 1's cancel. I get 2 times x plus 1, plus here the x plus 1's cancel. 3 times x minus 1 equals, here I'm going to FOIL, that's a difference of squares. So that's x squared minus 1. Now, this is a quadratic. Distribute, get rid of fractions, and try to solve it all out. We get 2x plus 2 plus 3x minus 3 equals x squared minus 1. Over here, 2x plus 3x is 5x. 2 minus 3 is negative 1 equals x squared minus 1. That's a quadratic, so do exactly what we do for quadratics. Bring everything to the right, set it equal to 0, and solve. So I'll get 0 equals x squared. That's a 5x subtracted, so that's minus 5x. Negative 1, if I add it over, I get plus 1 minus 1, which is 0. And I get 0 equals x squared minus 5x. I want to solve that. In this case, there's a common x. If I factor that out, I get 0 equals x times x minus 5, which then gives me my solutions. X equals 0 or x equals 5. And now, again, in this case, you'd have to check to see if those are extraneous. If we do it really, really quickly, if I plug in 0, I get 2 over 0 minus 1, so that's 2 over negative 1, which is negative 2. 3 over 1, which is 3, equals 1. And clearly, 3 minus 2 is 1, so that checks. If you plug in 5, you get 2 over 5 minus 1, which is 2 over 4, plus 3 over 5 plus 1, which is 6, so that's 3/6, equals 1. That's 1/2, plus 1/2 equals 1, which clearly works. So both solutions will work, and in this case we don't have any extraneous solutions. Again, much like with radical equations, there are lots of different ways to kind of see these rational equations and all like this, but the setup is the same. Find the common denominator, multiply by it to clear the fractions out, and then do the resulting algebra. Sometimes you get a linear equation to solve, sometimes you get a quadratic. It varies based off of the problem. The key is to understand this basic trick right here, multiply by the LCM. And then for both types of equations, make sure to check for extraneous solutions.